Okay, so welcome back. And so now what we want to do is we want to do an example. And so in this example, we're given this function, f of x equals the square root of 1 plus x. And we want to find the binomial series that represents this function. So it might be helpful to write this as 1 plus x to the 1/2 power. And so in this case, we see that r equals 1/2. And so now all we have to do is apply this to the formula. So we see that this is equal to the summation of n equals 0 to infinity of r choose n x to the n. And so we start with, well, it's going to be 1 plus rx plus r times r minus 1 over 2 factorial x squared plus r times r minus 1 times r minus 2 over 3 factorial x cubed plus dot 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 plus, and then of course we got r times r minus 1 all the way to r minus n plus 1 over n factorial times x to the n, and of course it keeps going on like that. So what would this look like, right? Well, now we're just going to put in 1/2 for r. So we know this is going to be 1 plus 1/2 x plus, well, this is going to become what? It's going to become 1/2 times 1/2 minus 1 is what? -1/2. Okay? Over 2 factorial x squared. And then the next one is going to become what? It's going to be 1/2 times -1/2. And then what? R minus 2, well, we're going to subtract 1 from this one, right? That's the same thing. So now we're just going to get -3/2 over 3 factorial times x to the third. And what do we end up with? Well, these two, still trying to see, because we could simplify that. Because we got 1 plus 2x. This is going to become minus 1 over 2 squared times 1 over 2 factorial 2 squared, like that. And then this one is going to be plus because the negative times a negative, but we're going to get, now we're going to get 1 over 2 cubed times 1 over 3 factorial, but then we've got this 1 times 3 in here. Right? And so if we simplify this, these first two are positive, but then it alternates. So actually the first one, so actually this pattern starts up right with this one, right? 2 to the first, 2 squared, 2 to the third. So, and then it starts plus, negative, plus. So if we just don't include the 1, this is what we end up getting. We end up getting 1 plus the summation, and we end up getting negative 1, and we get 1 over 2 and 1 over n factorial. So I think that's going to be 2 to the nth power. Yeah, so this will be to the nth power. So this is going to be, oh, this is going to be to the, so this will be n plus 1. Okay, so this will be n plus 1, and this is positive, so this will have to be equal to n plus 2, n equals 1 to infinity. Since we're not starting at 0, we're starting at 1. So that'll work. So that'll make that positive, and then this will be negative. And then, what else? Oh, so what's going on here at the top is we got 1. We've got 1, 1, and then 3. And then this is going to end up being 1 times 3.
Call from 1-815-753-2815.
Times 2n plus 3. No, not no, that won't give me minus 3. Minus 3. Yep. 2n minus 3. And of course, times x to the n. And that's it. So now, what we want to do is now they ask us to use the third order Maclaurin polynomial P3 of x to estimate the square root of 1.5. Use Taylor's theorem to bound the error. Use a graphing calculator. Again, we're not going to graph this, but you can do that on your own. Okay, so now let's use the third. So now that we have what this looks like, now what we want to do is we want to estimate the square root of 1.5. Okay, so let me erase everything up to this part. And so we want to use P sub 3 of x, okay, based on this, to estimate. Well, let me do this. Okay, which we can write as the square root of 1 plus 0.5. Aha! Which is our x value. And so since x is less than 1, we know that it converges. And so we could use P sub 3 of x, okay? Which means that this is going to equal 1 plus what? This is going to give us 1 plus r times x plus r times r minus 1 over 2 factorial times x squared plus r times r minus 1 times r minus 2 over 3 factorial times x to the third. But in this case, x is 0.5. Right? So again, we could use the pattern here, and it's going to give us 1 plus 1/2 times 1 over 2 factorial, right, times 1. Okay, plus 1, 2 squared times 1 over, hold on a second, 0, 1, oh. Let me start over, sorry. I missed a term. So it's 1, and then this is going to be r times x. So this is going to be 1/2 times 0.5. And then this is going to be minus 1/2 squared times 1/2 factorial times 0.5 squared. And then this is going to be plus 1/2 cubed times 1/3 factorial times 0.5 cubed. And that is where we're going to end. And so, of course, this you can easily do in your calculator, but so this is going to be 1 plus, this is going to be 1/4 minus, this is going to be 1/8 times 1/2, which is 1/16. Times 0.25, which is 1/4. Plus 1/8 times 1/6 times 0.225. Oh, no. 125. Nope, actually, I forgot about the, hold on a second. 1, 3, there should be a 3 up here. And this should be 3 times 5. Okay, there you go. And so this would be 3. 3 times 5. Okay. Actually, let's do it. Hold on. Let me do it this way. So this is 1 plus 1/2 times 1/2 minus 1/2 squared times 3/2 factorial times 1/2 squared plus 1 over 2 cubed times 3 times 5 over 3 factorial times 1 over 2 cubed, right? Oh, hold on. That's why. It's 1, 1. There we go. And then 1 times 3. Yeah, okay. So this is x. Yeah, let me do this way. So x squared okay, let me just start over. So this is going to be 1 plus 1 half x minus 1 over 2 squared times 1 over 2 factorial times x squared plus 1 over 2 cubed times 1 over 3 factorial times 3 times x cubed. Okay, so that's what we have. So just x. And so this is going to become 1 plus 1 half x. This is just 1 over 2, so this is just going to be minus 1/8 x squared. And then this is 3 times 2 times 1. So this 3 is going to cancel with this 3. So again, I get 1 over 2. So this is going to be 1/16. So plus 1/16 x cubed. Okay, there we go. Okay, so all I'm doing is following this formula. Okay, I got mixed up a little bit trying to do 0.5 in there, so I just figured just do it one step at a time. And so now stick in 0.5. And you get 1 plus 1/2 times 1/2, right? Minus 1/8 times 1/2 squared plus 1/16 times 1/2 cubed. Okay, so that's where I was before. I had the same thing, but I just wanted to erase it and rewind a little bit. So now, if you stick this in your calculator, you'll get something that is equal to what? It's approximately equal to 1.2266. Okay, so that is the approximation for the square root of 1.5. So, therefore, we know that the square root of 1.5 is approximately equal to 1.2266. Now, from Taylor's theorem, we know that the error has to satisfy the following. Okay? So we know this error. So this is approximately equal to 1.2266. Okay. Now we're going to talk about the remainder and found this error. Okay, so we know by Taylor's theorem that R, so 3 of 0.5, or a half, has to equal f of 4 of some c value over 4 factorial times x to the 4th power. Right? So, but again, it's just a half. So it's x is a half, so it's going to be 1/2 to the 4th power. Okay? So we know that there has to be some c on the interval, right, from 0.5 that satisfies that. So, what is f of 4? Okay, well, f of 4 of x equals what? Well, think about it. So this is the square root of x, right? So the first derivative is 1 over, it's negative, or no, it'll be 1 over 2 times the square root. So if we just, again, just go through it, right? So f of x equals the square root of x. So f prime of x equals what? It's going to be 1 over 2 root x. Okay? And then the second derivative of x is going to equal what? Negative 1/4. Hold on a second. Yeah, hold on. Yeah, so being x to the 3/2, and then the third derivative of x is going to equal positive 3 over 8x to the 5/2. And then the fourth derivative is going to equal what? That's going to equal negative, and it's going to be what? It's going to be 15 over 16x to the 7/2, right? Okay, but again, since this is 1 plus x, this is actually 1 plus x, right? Because we're actually dealing with the square root of 1 plus x, not the square root of x, okay? So this would just be 1 plus x. But again, it doesn't change anything because the chain rule, the derivative of 1 plus x is still the same. It's just 1, okay? Okay, so now, that we have this as our fourth derivative, we need to figure out what the bound of this thing is. So again, we're going from 0 to 0.5. Now here's the thing, we want, this is on the denominator, so we need this to be the largest it can be, right? Oh, and by the way, we're taking the absolute value of this thing, right? And so we want to see what the maximum value of this thing is in absolute value. Okay. And we want to do this on the interval from 0 to 0.5. And since this is in the denominator, we want this thing to be the smallest, because if this thing is the smallest, then that means this will be maximized, okay? So the value that will make this the smallest is the value of x that is the smallest, which is 0. And so, the maximum value of this thing when x is 0 is what? Well, 15/16. And there's our capital M value, our bound, our upper bound. Okay. So now, what do we get? We know that r of 3 of 1/2, or the absolute value of that, has to be less than or equal to what? 15/16 times 4 factorial Okay. And so what is this approximately equal to? And that is our error bound. So what does this mean? By using the third Maclaurin polynomial to estimate the square root of 1.5, our estimated value is 1.2266, and we are within 0.00244 of the true value. Okay? And that's it. Have a great day.